Welcome back. Well, recently you watched my daughter and I pour the slab that goes beneath that oven base right there. That oven base basically is situated 4 feet below the grade. Some people ask me what I was doing way down there. Well, you know, in this climate you have to be 4 feet below grade in order to be below the frost line. That prevents upheaval and buckling of the concrete, which believe it or not, you know, despite the weight of that, concrete will be pushed up just like it was marshmallows, nothing to it. So it would break it up and it would distort the whole measurement. But anyway, this is the point we're up to right now. The top slab has been poured, and it'll be a week in tomorrow. So I've been sprinkling that and keeping it wet. It's essential to keep concrete from curing too soon. You don't want to have it cure too rapidly because you'll lose the strength. The concrete, the crystals in the concrete have to be able to grow and to become strong over at least the first 7 days. You know, concrete continually hardens as time goes on, but those first 7 days are very critical. So by tomorrow, I'll be able to shut off that sprinkler, and I'll consider that to be sufficient. I want to take you on a tour of what we've done so far. If you look behind that corner, that concrete slab, which is 7 feet and 7 feet from one side to the other, you'll see it also has a protrusion on the other side. That's going to be at the deck level, and so basically that's going to be a fireproof hearth. So any embers, hot coals or anything that might dribble out of the oven will fall onto that rather than falling onto the flammable wood. The deck is going to be in dimension. It's going to be 16 feet wide as it was before, but I'm going to be removing all the old decking material, and it's going to be extended out to 24 feet. In other words, to the same edge as this concrete. So as you can see to the side here, over this corner right here, this is out 24 feet from the house. So it's going to be quite large. It's going to be a very spacious area. Basically, I'm going to build an outdoor kitchen. I'll be able to have my Napoleon grill under cover. There's going to be a pavilion. I'll show you on a drawing that I've cooked up on Sketchup Pro. I've been using Sketchup Pro now for some time to draw all my designs. I used to do it on graph paper, and dimensional graph paper was a lot of fun to do things over the years. But I've learned to use Sketchup Pro, which makes things an awful lot easier, and really I can do a lot of detailed drawing, architectural style drawing, or even stuff that I weld up. You know, if I want to weld up a forklift attachment for my 3-point hitch on my tractor so I can move the beams around that I'll talk about. It's easier to draw it up on SketchUp Pro and get all my measurements and cut dimensions exactly as I want and weld things up. So let's take it to the computer so I can show you exactly where we are so far. Now you saw my daughter and I pouring this 8 by 8 foot slab, and it's 5.5 inches thick, which is basically the thickness of a 2 by 6, the depth of a 2 by 6, and that resides actually below grade 4 feet. After this, then my son came in and erected the concrete blocks. Now these concrete blocks right here are all 8 by 16 standard concrete cinder blocks, and this entire cavity was filled with, I filled that with sand. Basically that equalizes the pressure from the outside so that we didn't have to worry about the sides buckling under the pressure of the surrounding earth. So that was all, I filled that all with compressed sand, the same exact density as the surrounding earth. And So you can see I'll bring up the grade level line again, and from this point here, now I constructed a form around this, and together we poured this slab right here. The top of this slab right here is the top surface is actually going to be exactly the same height as the deck level. This is going to be situated at the corner of our deck. So this portion of the slab here represents an area where you'd be standing, looking into the oven, and bring that up. And as you can see, that's a very, very large area here, and that's going to be supported by the actual oven is going to be supported by a oven slab, which will be very heavily reinforced. But I didn't want to have a wood box that was so cavernous as that. It would be very impractical to try to stack wood in there, and there were too many corners where junk would reside after a while, wood chips and bark and all those things. So because this is going to be a wood-fired oven, and we'll be using hardwood, seasoned hardwood, and the petitions that will actually be inside. I'll show you what the get rid of the slab for a moment here, and you can see now with the petition. This will provide very, very good support for that oven slab, in addition to giving me a nice smooth area to store wood. Now, I didn't represent it here yet, but this area, these corners right here are going to be filled in with concrete. And I'll build a temporary plywood petition right there. We'll grout that with concrete, so that'll be a nice smooth corner. And the same with these back two corners right here. We'll throw some concrete down in those to give that some support. And that's going to be basically the what the entire oven and its stand will look like. I should say that we don't have an oven on it yet. The oven will be placed atop this. And I obtained the oven kit from Melbourne, Australia, Melbourne Fire Brick Company, and they have a stateside warehouse facility where all those ovens are shipped to, actually in California and New Jersey. So once I placed my order, it came very, very swiftly. The owner of the company himself called me to notify me that the oven was on its way, and I can't wait to get to that stage of it. Well, before we can get to that, and by the way, a lot of this, what you see right here, this is just a visual representation. We haven't decided yet how we're going to finish off this outer portion. Probably it'll be maybe stuccoed with some Italian tiles on the inside on these two surfaces right here, and just for appearance, it's going to be a pizza oven, so I think some Italian tiles might look nice. And on the outer surface right here, down to the grade level, perhaps we'll either do some stucco, or maybe my son will veneer it with some form of stone veneer. He's a stone mason, and he does fabulous work. So this is what all the dimensions look like. You can see it's quite large. The actual oven surface upon which we can build that brick oven is going to be it's 7 feet by 7 feet, and it's a beautiful work surface. And I'll have a work surface on this side that will extend the other side to the other side of the deck, basically, where I'll be able to we'll be able to make pizzas. So let's show you what the how this is all going to be protected. One of the serious considerations that you have to deal with in freezing climates is the fact that water is essentially going to get into that mortar that the oven is made from, and it's a porous mortar. The stucco, which is on the outside of the insulating ceramic blanket, is absorbent, and if water gets into that, naturally freezing will cause it to start breaking up, and you don't want to have anything like that. So it's necessary to have a very good covering to protect it. And I want to be able to use this oven during the winter as well as summertime. So I don't want to just cover this with a tarp or something like that. Here's the pavilion I designed, and it actually incorporates an extension, because this from this post out, the previous deck was 12 feet by 16 feet wide. So from this edge right here near the house, it was 12 feet out. So what I did was doubled the distance. So now it's 24 feet in length from one edge to the other, and it's 16 feet from one side, from this corner to this corner. This is not this is a to scale representation of the dimensions of the deck, but it certainly doesn't represent what the deck looks like. So we'll get rid of that deck for a moment so you can see. And again, this slab right here is a representation of what will be there in terms of depth. In other words, the height of this area right here that I'm showing with my arrow underneath the post, that will be essentially 6 inches thick concrete, but they're going to be individual supports rather than being one entire slab. And we've determined we're on very, very stable ground. So our barn has been sitting for 15 years, 16 years on a slab that has never moved, and it hasn't cracked. So we're just going to allow those support bases to float on top of the sand. And again, sand is it's a wonderful thing to build on, because it has good drainage. It doesn't absorb, it doesn't keep water, so therefore you don't have heaving situations. And if you just simply put about a foot of heavy crushed stone, granite crushed stone, on top of that sand to stabilize it, it'll stay there forever without moving. Now, you can't do that with a dwelling structure, but this is a detached structure which is basically going to just float on its own legs above the deck. So it's not attached to any structure of any kind. So this gives you an idea of the dimensions, but you really have to understand how large this is. Each of these posts are actual 8 by 8 inches. In other words, that's not nominal dimensional lumber that you buy at the lumber yard, which has been planed down. These are going to be rough eastern white pine, and so each of these posts here are 8 by 8, approximately just less than 12 feet in height, and these are girts that span from this entire one section right here would be called a bent, and we're talking timber frame terminology here. So this one area that you can see me outlining with my mouse, that structure right there, which incorporates 2 posts, a girt, G-I-R-T, and this is a king post. That structure right there represents 1 bent, B-E-N-T. And what I did not do was draw in each of these wind braces. I don't need to draw in all the wind braces. I know exactly what they're going to be. This is for visual representation only. But what I did draw in are the pockets. These are all the mortises for to receive those wind braces and or knee braces. Now you can see this is a curious design right here. This is a complex joint, and this joint right here, this is indented 1.5 inches, and this girt right here is a 8 by 12. It's a massive beam. It's going to be 18 feet long from this edge right here, and I'll probably have this edge protrude somewhat. And you can see here there's a cavity, and that cavity is actually going to be filled with a long wedge that will be driven. It's a long tapered wedge that will be driven into that tightly. So you not only is that wedge going to be in there to prevent that from popping out. I'll show you what that actual. If you look on the inside here, I'm using Sketchup Pro to build this, and it really works out nicely because I can get all my dimensions, and I can be very, very sure of what I'm building and how it's going to actually come together. So I can get all my dimensions off of these drawings. So right now you can see this is the cross-sectional views. I can turn those on and off. But that tenon is actually tapered, and it's gonna fall into this joint right here, which is also tapered. So that will, once that wedge is driven into place, that will secure that girt beam to the post. And in addition to these wedges that will be driven in and then cut flush, there's also going to be 3 1-inch oak pegs placed into into each one of these, any one of these joints. There's going to be 3 pegs. And as you spin this around, you can see there's going to be wind braces at all corners, and they're going to be from the outside edge. Those are going to be 3 feet. In other words, the bottom edge of that wind brace, the knee brace, is going to be situated 3 feet from this top edge down here. And up here you can see there's a 5-inch tenon that goes into that beam, and that beam, that plate right there, is a 8 by 10. So we have different dimensions that we're working with. So this plate right here, and also the ridge pole, this is all gonna be 8 by 10. These rafters are massive. They're 4 by 10s, and they're very, very big. So 4 by 10 rafters, and with 4 by 10 rafters, they can be spaced quite far apart. So basically, they're going to be spaced at 3 feet 11 and 5/16 a piece. That's one of the nice things with SketchUp Pro, is you can just throw those beams in there evenly spaced, and it calculates the actual dimensions without having to go through your own computations. And to give you an idea of perspective, these purlins that will support a steel roof, the steel roof will be laid in parallel with the rafters, but these purlins right here are actually 2x4s, if you can imagine. So that gives you an idea of the perspective. These are actual dimensional 2x4s that you buy at the store, and those are going to be spanning the entire length. So that's what this whole project is going to be. My first endeavor will be to cut each of these posts, get each of these posts cut. And what I'm going to do, each of these mortises right here, traditionally somebody would outline each one of those mortises where they scribe them out very carefully and position them all, and then do it by chisel. I've got a chain mortiser I don't want to spend forever chiseling out mountains of chips. So I've got a chain mortiser. It's a Makita that will cut those mortises. There are quite a few of those mortises. I don't even know. I haven't counted them, but there's an awful lot of them, and they're also up above here. You can see there's also wind braces up in this supporting the king post, and that's going to be on both sides of those king posts. The center king post is going to have a wind brace on the front and back, and the two end king posts are going to be spanned with one. So and all those rafters will be. These rafters are actually. You have to depart from tradition, and code will require that I put GRK screws at least 4 inches into each of these plates and into the ridge pole. So those are going to be driven, and they're quite expensive. But those screws, there'll be one on each joint there to secure that. And that's, as I say, that's required by code because it certainly is not something that's going to be visually unappealing because you won't see it. But all those parts are going to be handmade. I'm going to be actually using a template to place the location of each of those mortises. I don't need to individually scratch out each one with a square. I can just make myself a plywood template that will fit down on the sides of each of these posts. I'll have one for each of the two dimensions. So it's going to be fun. I'll be getting at that right away. We've got so far the slab poured, the oven base built up to deck level, and as you can see, it's actually going to be residing. That oven's going to be residing right in this corner right here, this back corner. So that's where we are at this point. Now the difference between post and beam and timber frame construction is very simply how these joints are put together. Timber frame construction is all basically the style which was used back in Europe for hundreds of years, and in this country in colonial periods and up until the 1800s and more, where everything is in making barns and houses and all sorts of buildings where timbers were placed together with mortise and tenon and hardwood pegs. And that's what this is. So that's a timber frame construction. Post and beam construction uses steel fasteners, plates and nuts and bolts, which hold those corners together. Overall, I mean, they're both extremely strong. Aesthetically, the timber frame construction is very, very eye appealing. It's also, it's also less costly. If you had to pay a laborer to do it, it would be much more costly. But if you can do it yourself, certainly reduces the expense of having to buy hundreds of pounds of steel plates and bolts. And although that's a little bit easier to put together, I think by the time I get this done and get all these joints put together, I think it's just going to be a very rewarding experience for us all. How we're going to get these things up in the air is another thing. It's a bridge we're going to cross when we get to it. I believe I'm going to be using a forklift with a 40-foot reach. Basically, I'll be able to drive these things into place. In other words, lift them up into place by just driving over with it's basically a tractor style machine with a 40-foot long telescoping forklift. And so this beam will be lifted up in the air, and with assistance, I'll raise the posts on the side and buckle them together. And of course, they have to be situated on the bottom of those posts. Have to be situated on top of fasteners. The Simpson strong tie bases, which are bolted to the concrete, and elevate the post above any water. And I'll be using at the bottom of that post, I'll be using a waterproofing substance to prevent uptake of moisture into the grain of the wood. So you'd be surprised how many barns and houses have been standing for 250 years in this country that are just simply sitting on a slab of stone. And those the same posts have never rotted. So as long as it's pine will last for a long time, as long as it's protected from sucking moisture up into the grain. So and in old days they used simply tarred the end of those posts to prevent uptake. What you do not want to do is surround the post with creosote or anything, because that has been found. Actually, the railroad found many years ago that by just dipping railroad ties in creosote, that the creosoted wood remained stable, but the interior of the wood got wet and it rotted out. So basically, it had a waterproof shell, but the inside turned to rot. So you don't want to surround. You want to have allowance for that wood to always dry out. So while you make the end grain waterproof, in other words, as you're looking up from the base, that section right here will be waterproofed, and that should maintain its integrity over the years. So that's what we have. It's going to be quite a challenging project. I'm looking forward to getting it completed, and I'm basically racing against the clock, because here we are. It's mid-July. I want to be working in nice weather, and I don't, of course, we can expect snow anytime after October into November. So I certainly want to have the oven built long before then, so we can have it all covered and enjoy it. So Benny's been my assistant this whole time, supervising me, making sure that I get things right, and he's always by my side. I've been very blessed. Many prayers that people have said for Benny and for us. He's been almost 4 years now since he had his cancer, so he's doing fantastic. He's getting a little white around the muzzle, and but he still gets around really good. His weight's good. He still leaps and bounds all over the place, so he's a good guy. So that's what we're building so far. I'm sitting on top of some of my, all these are my 8x8 corner posts and center posts. But I'll be taking you through this process, and in addition, when time permits, I'll take you out and we'll do some shooting too. Right now, I've had some fantastic response from patrons on my Patreon page. Unfortunately, the biggest problem is not having the wherewithal to purchase ammunition. It's getting ammunition. It's trying to find it. I'm trying to find some, for instance, 22-250 ammunition to do some testing with that. Different manufacturers. I don't want to just bring out 1 or 2 boxes of ammo. And in all fairness, I want to be able to have a representation of what different brands do. But it's very difficult to obtain ammunition. It's a matter of supply. So that's it. But we're going to continue on with this construction project. The next thing I'm going to be doing is, as I mentioned in just a moment ago, I'm going to be cutting my posts, my corner posts. That's the very first thing. Then I'll cut my girts that go across, that buckle them together. And then the plates, which go longitudinally all the way from one end of the deck to the other, and the ridge pole. Those are going to be, by the way, those are going to be scarfed. In other words, the two, rather than having one long 24-foot ridge pole, they're actually going to be scarfed together, two ridge poles that are going to overlap each other by 2 feet and it's done in a special way so that they remain stable over the years. And those scarves are going to be positioned directly over the center post. So there's a lot of work to do in the meantime. So thanks for watching. Be sure to hit that subscribe button and the bell so you're notified when I put up a video. So Benny and I will bid you adieu, and God bless. There's Benny. Hey, come on, I gotta do some digging. That would replicate the height of the